Delaware Tech, Chemistry 100, Unit 3, continued, Modern Model of the Atom and the Orbital. So in 1926, Erwin Schrödinger worked out a new mathematical model that illustrated where he believed the electrons were located in an atom. Remember, Bohr, before this, working with Rutherford, had decided that the electrons were in orbits, essentially moving around the nucleus the same way that planets move around the sun in our solar system, but not all in the same plane. And they knew there were issues with this, and Schrödinger came up with a new model that really shattered the old model. However, Schrödinger had a lot of help from other people, including Werner Heisenberg, Niels Bohr, whose model he shattered. So Bohr was in on revising the model in a big way, and a lot of other scientists, and some of these you'll hear about later in the next unit, Pauli, Hund, and Aufbach. So shown in this photo, I show this. This is jokingly referred to as the most intelligent photo ever taken. Taken in 1927 at the 5th Annual Solvay Conference in Brussels, Belgium. 29 physicists in this photo, 17 of them won Nobel Prizes. And just point out in the back row, you'll see Schrödinger and Heisenberg back there. Pauli's actually one of the ones between the two. In the middle row, there are a number of other giants of physics: Debye, Bragg, Dirac, de Broglie, Born and Bohr, Niels Bohr. And then in the front row, Max Planck, who discovered the quantum, the smallest unit of energy. Madame Curie, who everybody assumes is French, and she was French. She was French as she adopted the country of France. But the fact is, she was actually born Marie Sklodowska. She was Polish and married Pierre Curie, another prominent physicist. And while there are many stories about Madame Curie, it should be noted that while she was the first woman to receive a Nobel Prize in any subject, she is to this day the only person of any gender to receive 2 Nobel Prizes in 2 different sciences, chemistry and physics. In fact, she won a Nobel Prize with her husband. She won one by herself. Her daughter, Irene Curie, won one with her daughter's husband, Frederick. And so the family is probably the most prominent Nobel family in history. We also have Einstein right there in the center. And so this is a real pantheon of who's who in the physics world in the 1920s. These were the people that essentially created the modern view of atomic chemistry and atomic physics. Now this page right here is really for Chem 110, and I'll skip this. There'll be a separate unit for that. This is mostly Chem 110, but I'm going to include it because there are some important points here to reiterate. The electron cloud was developed, and now the idea is that instead of occupying orbits moving around the nucleus, the electrons actually occupied volumes of space called orbitals. So they're not orbits. They refer to orbitals only to be a parallel word to the older word orbit. They're really volumes of space where the electrons can be found in, and even more properly, they're volumes of space that actually are the electron themselves. The electrons really are smeared around in this volume of space. They're not particles like we think of so many other things in everyday life. They can behave like particles, but they also can behave like waves. You are not responsible for this, but the reason I bring this up is there's a concept known as quantum numbers, and these are not for Chem 100, but they do illustrate something you're going to need to know for the next module, which is electron configurations. These quantum numbers, there are 4 of them. The first one, called N, is the energy level. In other words, how far away on average the electrons are from the nucleus. There's level 1 that's close, level 2, 3, 4, 5, they get further and further away. And within each level, you will find different types of orbitals, different shapes of volumes, different volumes of space where the electrons occupy. And they have different letter names, S, P, D, F, We don't have any elements currently that are big enough to have G's, but literally, probably in the next 10 years, we will. We need 3 more new elements to be discovered to hit the G's. But right now it's just those types. And that's the second type of quantum number. We assign each of those numbers. You don't need to know these numbers. I'm just pointing out that there are energy levels, and then there are orbital types. And then within each orbital type, there are suborbitals. In other words, each orbital has made one or more different versions of that orbital within a single energy level. And then spin refers to the fact that you can stick 1 or 0, 1, or 2 electrons in every suborbital, but they have to have what we call opposite spins. Don't worry about the numbers. Just know that there are 2. You can put up to 2 in every suborbital, but they have to be different in some way, and that quantity that we say is different, we call it spin. It's not truly spin, we just refer to it as spin. So, the orbitals, these are mathematical volumes of space that are defined, and Schrödinger worked this out, and with a lot of help from mathematical physics work from Heisenberg. So, as I mentioned, these volumes are regions of space where the electrons are found, but more properly, they're regions of space where the electrons actually are most of the time. We can't show where they are all the time because sometimes electrons can be anywhere. So they're shapes that essentially are 95% of the time. Don't worry about that. It's just the definition. So the electrons are the volume of space. And like I said, there are many types of orbitals. S, P, D, and F are the 4 you do need to know. And one way to remember that is the phrase speed factor. So S, P, D, and F, it tells you the correct order. S, then P, D, and F. These letters actually stand for words that are a bit esoteric. They're beyond the scope of the course, so I'm not going to tell you those because they'll just confuse you more. So each type of orbital has its own shape or types of shapes. And each orbital can come in groups of 1 or more. They're always odd numbers. S's come in groups of 1, P's come in groups of 3, D's come in groups of 5, F's come in groups of 7. You see they are sequential odd numbers increasing by 2 each time. So if we ever get G's, they'll be in groups of 9. So the S orbital, it's 1 suborbital per energy level. They start right at the first level. Not every orbital can be found in every energy level. At energy level 1, the only kind of orbital you find are the S orbitals. And the S orbitals are spherical. They might be solid spheres, they might be spherical shells, but they're spherical. You can remember that if you want. You don't need to know the shapes for this, but the S does not stand for the word sphere. It stands for something else, but that's one way to remember them. So remember, every suborbital, in this case there's only 1 per set of S, can hold up to 2 electrons. No more than 2. They can hold 0, it can hold 1, it can hold 2. So the maximum an S orbital can hold is 2 electrons, 1 times 2 electrons. And we would number these, depending on their energy level, as 1s orbital, which can hold 2 electrons, a 2s orbital that can hold up to 2 electrons, a 3s orbital that can hold up to 3, etc. We also have p orbitals, and they come in groups of 3 for each energy level. They are only found, they're not found in the first level, but they're found in every level after the first level. So there are levels, you will find them at the second level, the third level, the fourth level, etc., but not at the first level. And they're shaped like dumbbells, really fat dumbbells, fatter than these pictures really imply. And because you have 3, they come in groups of 3, and each one can hold from 0 to 2 electrons. 3 suborbitals times 2 electrons each gives you a total of 6 electrons can be held in a set of p orbitals. So you can have 0, 1, 2, 3, 4, 5, or 6 electrons in a set of p's. And we call these the 2p, the 3p, the 4p set. They're each a set. And they can each hold up to 6 electrons because they're each a set of 3. Notice there's no 1p. We also have the d orbitals, and the shapes get more complicated each time. These come in groups of 5. They start at the third level. So you'll notice each new one is appearing in the next energy level. You always get a new one. Every time you move to the new energy level, there's a new kind of orbital that's also available. So the Ds start at level 3. So we have 3D, 4D, 5D, etc., but we don't have 1 or 2D. And the shape of these are cloverleaf most of the time. One of them is a dumbbell with a little donut around it. They all can hold up to 2 electrons, so 2 times 5 suborbitals is a total of 10 electrons in a set of d orbitals. We look at f orbitals, as you can guess. We already looked at groups of 1, 3, and 5 suborbitals, so these have 7 suborbitals. And they start at level 4 on this one, because the others started at level 1, 2, and 3. F start at level 4. And the shape of these, remember, first you started with a sphere, which had no lobes or 1 lobe. Then you went to dumbbells that had 2 lobes. Then you went to cloverleaf that had 4 lobes. Well, now you're at something that has 8 lobes most of the time, but one of the 7 is this dumbbell with a double donut around it. So most of them are 8 lobes. You don't need to know the shapes, but you should know they get more complicated each time. And no matter how complicated they are, each of these suborbitals can only hold 2 electrons each. So this is a total of 14 electrons. And since f orbitals don't start until the 4th level, we have a 4f, we have a 5f. If we ever make enough elements on the periodic table, eventually we might get to 6 f orbitals. So, to review, the s orbital, p orbital, d orbital, and f orbital type, they each start at different levels. So s orbitals are at every level, 1s, 2s, 3s, 4s. P's, there is no one level p. There's no 1p set of orbitals. We have a 2p set, a 3p, 4p, 5p, because they start at level 2. D start at level 3, F start at level 4. The number of suborbitals in each group is easy to remember. These are the odd numbers, so there's only 1 S in each set. There's 3p in each set, 5D in each set, 7 Fs in each set. If we get the Gs, there'll be 9 in that set, and Gs will start at energy level 5, as you might expect. So if we take the number of suborbitals and multiply each of the numbers in the second column, we get the maximum number of electrons we can put in that set of orbitals. So we can put 2 in a set of Ps, 6 in a set of Ds, 10 in a set of Ds, 14 in a set of Fs. Remember those numbers, 2, 6, 10, and 14. They're going to come up later in the next unit.